Hi, my name is Steve Van Dockenberg. I'm a mentor for CyberCabs at 4678. I've been doing this for, I think, 7 years. I can't quite remember. Um, but yeah, so something that we've taken a lot of notice of is to try and tapping into the students' ideas and getting them to be able to show us their ideas. And using an electronic tool like Autodesk Inventor has been a great way for students to be able to experiment with different ideas that they have and being able to better articulate exactly the ideas that they have. And so using Autodesk as a communication tool and as a design tool has been very valuable. And so we wanted to kind of take an opportunity to give some of the basics of Inventor, how to use it, a bit of a navigation through the tools, get into some things that first are fairly straightforward, and then moving into being able to create your own parts and create even your own whole assembly. I'm not sure exactly how long or how many sessions this is going to be. Um, I've offered this in person over the last number of years, and it works great. But I've tried to alter the curriculum for it to be more apt for online for this kind of learning. So we're going to learn together what works best and go through some of this stuff. So without further ado, let's start with this Inventor training. When you first start up Inventor, if you don't have Inventor started, please do so now. The method that we're going to use in this training is kind of a walk along. So as I show you, as I explain different features and things like that, I would like you to try and keep up with what we are doing. If you end up being behind in something, it's okay. We spend a bit of time and we create multiple parts throughout this training. So if you get behind and you can't keep up with building the part, don't worry. You're not lost for the rest of the training, because at another point, we're going to start a new part again. And then you can always come back to the part later, watch the video and follow through and be able to complete it after the training is finished. So try not to get frustrated if you do end up falling behind, but I'll do my best to not let that happen. When you start up Inventor, you'll be greeted. You might have a little bit different of a screen when you start up. When you start up for the first time, it's got some. I think there's a start learning and there's a start working thing. If you see that, then do start working. It's kind of weird. It does it. Some people get that screen, other people don't get that screen. So I'm not exactly sure what their idea is there. But in the end, you'll end up in something that looks like this. And the first thing that I'd like you to do is to start up and create a new part. And to start a new part, you can pull this down here and in the upper left here and click new. Okay, so we're starting a new project here, and it lets you pick what kind of project you want to create. And for us, we're going to start out with a standard millimeters project. You probably won't get this dialog, so don't worry about that. Now, before we get in too much further, I just wanted you, sometimes it takes a while for Inventor to start everything up and load everything. So I wanted to get us doing that while I talk about the next few things. So that should be starting up and running for you. So in the meantime, a few things about creating your own designs. Initially, when you're just learning CAD, it's going to be much faster for you to sketch something out on paper and kind of think about how you want to build this part. As you become more proficient at the at CAD, you'll be able to jump in sooner into building your own parts. But my suggestion for you first is to start out and kind of plan out how you want to make the part. Right now, you don't really know how to plan that until I teach you some of the tools. But as we move on, the thing to keep in mind is to really plan your design. And sometimes that involves, starting with paper. Something else that you need to keep in mind when you are designing a part is to consider what type of tool is going to end up making your part. So there are certain things that you can do in a part that you can not do when there are certain things that you can do when building a part that's going to be 3D printed that you can't do if it's going to be milled. For example, if I pop open, this is a piece of software called Cura, and it is a slicer. And this is what ends up being used when we prepare a part to be printed. So you can see I designed a part here, and this is actually something that mounts on the side of a monitor. And then you can put drawing pens for like electronic drawing in here. And so there can be a charger where they sit in, and so they're always near the edge of your monitor ready to work, so you don't end up losing them on the desk or whatever. So a simple part that does all of this. You can see here that given how this part is designed, that there are pieces that kind of come out from a base piece. Most of the mills that we use for metal fabrication end up only being able to cut in a single direction. Okay, so for example, at Woodland, where I am a mentor, our mill can only cut mainly profiles. It can cut some 3D types of shapes, but the cutter is always vertical. It never goes to one side or another. You could achieve some of this by, mounting a part differently and things like that, but it would be hard to make this part in our mill. So to think about, is this going to be a 3D printed part or is this going to be a milled part, is something to keep in mind when you're creating your parts. This brings us to something called additive versus subtractive manufacturing. When we talk about 3D printing, what it is for those of you that have not seen a 3D printer, it is a device that takes in a filament, or actually the most common types of 3D printers. There are other kinds of 3D printers, but it'll take filament in, melt it into a very thin thread, and build up from the base plate up to the very top of it. So it'll build up on top of it. So if I do a preview here, this is what, when you start out building a part, it starts out at the bottom and starts adding, and it keeps adding material all the way up until it comes to the very top and the part is complete. Okay, so this is what's known as additive manufacturing. You are taking something that was nothing before and you're adding material to it to create the final part. The second is subtractive, and that's the kind of machine like a lathe or a mill that uses some kind of cutter that removes material from a piece of aluminum or steel or plastic or things like that. It's actually cutting to remove material. So we have additive versus subtractive manufacturing. If we look at this diagram here, we can see that our 2D drawing, as we say, create in Inventor, can then be used to go towards one of two different streams, either a subtractive manufacturing stream or into an additive stream. Okay, so you could start out with the same design tool to do either additive or subtractive. So it's really kind of handy that way. Sometimes you're able to actually prototype some parts in plastic to see if they'll do okay. And then finally put the final ones out of metal using a mill. So as you move through this process, you can run through CAM, which is basically telling a machine which tool to use to cut which aspects of the part, and it generates some stuff called G code, which you basically never really see. And then finally sending it to the mill for processing, or the lathe for processing. Similarly, you take a slicer, like I was just showing you before, and what it does is it breaks down the model into instructions and coordinates and how much plastic to extrude out of the tip for each layer to finally end up generating G code for it for running on the 3D printer. Okay, so starting out with CAD, as we're going to learn here, allows you to go in either a additive or a subtractive stream of manufacturing. And it's important to keep in mind what your final destination method is going to be when designing that part. So what next? The next part is we're going to actually start drawing a part. And when you start a part, you need to identify an axis or a plane that you want to work in. So to start doing that, you can click on the upper left button here that says Start 2D Sketch. And when you click that, you'll get a set of planes that show up in your work area here. And it's asking you which plane would you like to draw this sketch on. So as you go and highlight over each one of these planes, you'll see it highlight. So for me, I'm going to start in this XY plane. We have something particular about our milling machine that it needs to start in an XY plane. There's other processing that we can do to manipulate the cam later on to be able to compensate for it there, but it just, trust me, it's easier on our machine for our machine to use the XY plane. This is probably not true for anybody else's machine, but we've kind of got a homemade milling machine. So it's a little quirky. So go ahead and click on the XY plane. And now what it's done here now is it's created us a work area that actually is on that XY plane. Okay, so now what we can do is we can make sketches on here that are 2D, and eventually we'll make them into 3D parts. So that's how you end up building these types of models. You pick a plane to start on, you start sketching it, and then later we'll turn it into 3D, as you'll see. So our first thing that we're going to do is we are actually going to say, draw a square on this. And what we're going to do is we're going to make a square donut. Okay, so to start, go ahead and pick up the rectangle tool. And you can see you have a set of crosshairs. Now, if you watch where I am placing these, where I'm clicking, the clicking that I'm doing is I want to eventually, I'm thinking ahead here because I want to make this square centered on the origin, because that's what the instructions are telling me. The sketch should be centered on the origin. So what I'm going to do here is I'm going to actually make this square around the origin. It's not going to be, perfect, and that's okay. I'm going to make it perfect. Once you've finished drawing your square, you can see that you may still have a crosshair here. To get out of the tool mode, you can press escape to get out of the tool. Okay, it might want or be letting you create multiple squares like this. Okay, and so to get out, just press escape, and now you're out of the tool. So I'm going to go and get rid of this stuff because I don't need it. Okay, something else that you might end up doing that is a common mistake. Say you draw this square here, and you see in the middle here there's a dot, and this is origin. This is an important thing. So if I want to set dimensions or things like that, I can point at this and it means something. Okay, it says that this edge is going to be this far from the center. Okay, so this dot is important because you can anchor your sketches in a particular plane to a certain point. If you go through and you select this square and say, I don't want this square, I want to start over, and you select all of this, you're going to notice you've also selected origin. And then if you press delete to get rid of that, you've not only deleted the square, but you've also deleted origin, or the reference point for origin. Okay, don't worry about it. It's not wrecked. But what you can do is you can use this project geometry tool and expand out in your viewer on the side here and see all the different planes. And as I rub my mouse across them, you can see all the different directions of the planes. And then click on, so once you've selected geometry, click on center point. And once you've done that, you've brought that back. You brought that reference point back into your sketch. So you're still into this project geometry mode because your cursor is telling you it has an arrow and a plus sign, and hit escape to get out of it. Okay. So going back to our drawing here, we're going to start with our square. And the instructions here indicate that the donut should be 2 inches around all sides. So what we're going to do here is we are going to grab this dimension tool. And what the dimension tool does is it allows you to specify dimensions, lengths of things, angles of things, radiuses of things. It's a dimension tool that's aware of the type of geometry that you're assigning it to. So in this case, we're going to be assigning geometry or a length to this line here. And so I click that. Well, in the dimension tool mode, I click on the line and then drag the mouse away from the line to give us kind of a marker for what the length of that side is going to be. And I haven't left click to set it yet. I'm just moving the mouse up and down. To set the position of this, click on your left mouse button. Okay, now it's letting you decide what you want to do and assign a length to this. Since the drawing has indicated that, since the instructions have indicated that we want it to be 2 inches, I am going to type 2 and then IN for inches. Okay. Now, what you've noticed here is now the square is off of my screen. And that's because I've gone from 10 millimeters, whatever it was. I think it was 10 millimeters. And now I've scaled it up to 2 millimeters. Don't be afraid. You can roll away from you with your mouse wheel and you'll zoom back out again. Okay. To get the canvas to kind of move around, you can press and hold the middle mouse button and drag it around to actually position your part in a viewing area that you'd like. Okay. So we set that to 2 inches, but this says 50.8 millimeters. Okay. This is going to be hard for us to kind of always remember to when we're looking at our part to have to do translation and remember that these things are in millimeters. So we can change the units that this part will be built in. And so what we're going to do is we're going to go to the tools button or tools drop down menu at the top, and then go into document settings, and then select the units tab. I'm actually stealing some thunder from myself later on in this presentation. There's actually a piece in this dialogue later, but that's fine. We'll do it now. Change millimeter to inch, and then click OK. And now you see that all of my measurements that I've made have been converted into inches. So there's my 2-inch side. I'm going to continue with assigning dimensions by placing another marker here and setting this to 2. Now, because I have changed my units into inches, if I don't include a unit of measurement when I enter a dimension, it will assume it's the units of measurement that are set in the dialogue that we just did. So I can just enter 2 and it'll assume I mean inches and set that side length to 2 inches. The instructions also indicate that this needs to be centered on origin. There are a number of ways that you can go about doing this. What I have done in the past has been to create a construction line that goes from one corner to another and kind of divides this thing or places an X down into the middle of the square. A construction line is a special kind of line that isn't really part of the sketch. It's something that's used as a reference. Okay, so if you click the line tool and you draw a line, you'll see that it's a green line, a green solid line, and you can, move this thing around and draw. Okay, but this would actually be a piece of the sketch. We don't want an actual piece of the sketch to build on. Instead, what we're going to do is we are going to select line, and then in this corner, you see there is something called construction. And what's really great about this, especially for remote learning and things like that, you can hover over these different buttons, and it gives you a pretty good explanation right there as to what this is for. You still need to understand in general what that means, but it's a nice refresher to say, oh, okay, yeah, I remember what that is. Okay, so enable the construction. And so you can see it looks pressed in and the line is pressed in. And now what I can do is I want to draw a line now. Now you can kind of see as I get close to the corner that it kind of starts to snap me into that corner. You got to make sure that you're on that corner because that's where you want it to anchor. Okay. So I'm going to start with anchoring it there, and then I'm going to bring it down to this corner. And again, it kind of snaps into that corner. And that's what I want. So now you notice that the line has been drawn, but it's not a green solid line anymore. It's a yellow dotted line. And that indicates that it is a construction line. Okay. Repeat the procedure for the other two corners, and you get two construction lines. I slipped off the corner there. I'm going to redo that a minute. Okay, so now what we've got is we've got a square because we got 2 inches by 2 inches, and we've got construction lines that go from corner to corner, which means that the center of this square is the intersection of these two construction lines. Okay, and now we got to get these things over to the origin. Now I can try and position this manually if I can try to, but that's not good enough. Okay, I want it to be precise. And so to do that, you are going to be using these sets of constraints a lot. So get used to them. We will be using a few of these over the course of this training in the next sessions. The first one we're going to use is this one called coincident constraint. So click that, and you can click on origin, and then click on the intersection point between those construction lines. And now a bunch of things have happened. So let's talk about what just happened. Okay, I'm gonna hit escape to get out of that tool. A few things just happened here. A few lines turned into different colors. Okay, so we've gone from green lines and yellow lines into some that are blue and kind of purpley. Okay, what that indicates is that these are constrained. They are limited into where they can move. If I try and move this, remember how I could move the square before? I can't move the square anymore because it's all locked into position. The size is set, the center is set. There's no way you can move this thing. This is where it needs to be. So a fully constrained sketch is a great place to be, because after that, you can start making changes. So say I wanted to make this a 4-inch and I wanted it to be a rectangle, I can do that. Okay, and it still stays constrained. And so now I can change some of the parameters of my sketch and it will react properly. Now, one of the what ends up happening is that when we ended up constraining this, and since this construction line is locked to these two corners and the intersection is locked to the center, it ends up saying that this line is fully constrained and this one isn't, because this is an implied constraint at this point. If I try and constrain this, it's going to say, no, 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 I don't need that constraint because it's already fully constrained. So this constraint isn't required to be able to fully constrain your sketch. So that's why there's a color difference there. So the next part of this is to make a hole, a square hole in the middle. Okay, so at this point, I'm going to do something similar. I am going to draw another square. Oops. So this happens. So you see here, I still have construction still selected here. And now I've drawn a line and I can, you know, I see that it's construction. I don't want it to be construction. There are a couple of ways you can get out of this. The first is to select a line and then deselect construction. So each one of these, you can go back and say, no, 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 I don't want that to be a construction line. I want that to be a real line. Okay, so you can do that manually. That's an okay way to do it. For me, I would just hit Control Z at that point just to undo it, uncheck or unpress the construction line, and I draw my rectangle or square again. That's how I would end up doing it, but you can do it either way. You may discover that there are times when you have a construction line, you didn't notice it was a construction line, and so selecting the line and unselecting construction button may be the best way to do that. So we once again have a square that needs to be centered. Now we can use the coincidental constraint to do this. Again, we can grab a corner here and say, now I want this corner to be locked to that constraint line or to that construction line. Okay, I'm going to press escape here because I'm going to show you what's going on. Because what's actually happening here is if I go and I move this, you can see that I can move these things and you can see how that corner tracks with that construction line. It makes sure that no matter what happens and how the other parameters of this square change, it's going to make sure that this corner stays on this construction line. So as I move this down, you can see that corner tracing along that construction line. Okay, that's great. That's what you want. The second thing we're going to do is we're going to take a side, we're going to use the dimension tool, and we're going to dimension one side of it and say it's 1 inch. And then this other side, we also want to make it 1 inch. Okay, so now we're getting closer to having this thing be constrained. The next step is we're going to take this coincidental constraint again, and I'm going to zoom in here so you can see this. I'm going to grab this corner again, and then as I hover over top, you can see the construction line highlights. I click that, and now it's locked in on that. Okay, I'm going to press escape again because I'm going to show you something else that's going on here. Okay, so right now this isn't fully constrained. This is still green. And if you're looking at this and you can't figure out why it's not fully constrained, here's a trick that I do. I will grab a side that isn't constrained and I'll move it to see why it's not constrained and just move it around. And if I have it moved out of position, I go, well, I don't want it there, I can hit Control Z to go back. But what I've learned is that I've learned what constraint is missing that I need to correct. Okay, so at this point, I can see that because this construction line was not anchored to this corner, that it's allowing all of this to float. Okay, so I'm going to take the coincidental constraint again, and I'm going to say this point here, I want to lock to this point here. So now I've locked everything together. Okay, your drawing I thought originally that I had actually I had locked that construction line to that corner, but apparently I didn't. So yours might have already gone into fully constrained, but because I missed that, it gave me an opportunity to be able to show you how I determine when a constraint isn't applied and the freedom, the direction of the freedom that you get that you need to limit to lock it in. So now we have this sketch, and that's great. Okay, so now this is the 2D thing that we are going to convert into a 3D thing. So at this point, go ahead and click Finish Sketch. And now we are out of this sketch mode. So we no longer have the sketch buttons enabled. All these things are disabled because we're not in sketch mode. Okay, we're kind of not in any mode right now. So what we're going to do is we're going to go into 3D model. And at this point, we are going to click on extrude, and a dialog will appear that allows you to enter in some extrusion parameters. We look back at our drawing or at our design here, and it says all sides of the cube should be 2 inches. Well, we got this side that's 2 inches, we got this side that's 2 inches, and now we want to actually extrude the third dimension here, and we want to extrude it by 2 inches so that we actually get that cube now. So now we have 2 inch by 2 inch by 2 inch cube by using this extrusion. Okay, and we click OK, and now we have our square donut. We can use the home button here to orient our part so that it presents it to us. We can use this square, navigation square at the top here to move this thing around. We can click on a face of this navigation to show us, say, the right side, and use the arrows on the side to see the front, and then the left, and then the top, and then hit home to come back. So that's how you end up navigating your part to move it around. So for the next part, what we're going to do is we're going to build something a little bit more complicated. So what I want you to do now is click on File and then New. And we are going to start a new part. And then once again, we are going to go up to the Tools menu and then Document Settings. And go over to the Units tab and change this to inch. And then click OK. So I can see by looking at the instructions here that these things are all in imperial, measuring in inches and not in metric. So that's what we're going to do. I'm going to blow this up a little bit because what I want to do now is I want to open the session up for people to do this as an exercise, because we're kind of at a point where we can actually create this part. Now, this part is something that we build all the time in our robots, and there's different flavors of it at different angles, but a lot of times you want to connect 2 1-inch square pieces of aluminum together, and to make that kind of stick and be supported, you build a gusset, a plate that goes around on either side of those 1-inch pieces, and they are riveted to the 1-inch pieces so you can make this corner strong. And if you can put another gusset on the other side of it. So these 2 plates sandwich in 1-inch square tubing to kind of make a corner, a structured corner. Okay, the size of the rivets that we end up using require a 3/16 hole. So that's why those smaller holes are measured out to be 3/16. And the thickness of the plate that we use sometimes varies depending on how close we are on weight limits for the robot, but they're usually 3/16 thick. So that's what we're actually going to do here. That's a little overkill, but that's what we're going to do here. So this is the sketch that I'd like you to make. And then I'm going to open it up for questions or any other things, questions on anything that I've done so far, or on any of the, how to get constraints to work on. Your goal here is to get this fully constrained. And as a hint, what I've done here is I've set this corner in the upper left-hand corner of this part to be locked to origin. So there's a little hint for you for how to lock the thing in. So how do we go about opening this up now, Daniel?
So people, if you want to ask any questions, please feel free to unmute yourself and ask those questions, or you can type it into the chat and then we can read it from there. If anybody wants to share their screen, I can Yeah, I think it's set up to all participants. So if we get out of the screen sharing, then other people can share as well if they wish to do so. But let us know ahead of time. Any particular questions, any concerns, or how to start with this?
And the questions can also be on anything else that has been presented so far too. This doesn't have to be about this particular sketch. I'm going to start sketching this part. And if you are stuck, you can follow along to see how I would do it. And, or you can work away at yours and then, try and come up with the solution yourself. But how I would go about doing this is you could take the outside perimeter of this and start locking it in and, making the exact lengths of lines that you need and so on. So things like this. I'm going to start a new part. We've started a new part and I'm going to go to sketch and say start a new sketch. And then I'm going to just out of habit, I'm going to select the XY plane and I can start with a line and I can say, okay, so they asked us to make it a 4-inch edge. So I'm going to do this and lock this in and do 4 inches. And I'm going to dimension this and make this 4 inches. And great. Oh, it scaled out. Zoom out so I can actually see the part. And then it says this edge is supposed to also be 4 inches. So I'm going to do that, bring this down to 4 inches. And I've got that so far. And I can grab this and move this off to the side. Okay, you could do this, taking each one of these lines and then copying it and drawing each individual line onto the sketch area, but it'll take you forever. Well, it won't take you forever. It'll take you longer than a method that I'm going to show you. Okay, so what I'll end up doing is I'm planning the part in my head because I have this experience. I'm planning how I'm going to actually build this sketch. And so what I'm going to do here is I am going to get rid of this. Actually, I'm going to hit Control Z here to get me back to just my regular drawing. And what I'm going to do here is I'm going to kind of roughly draw those lines. So I'm actually going to go click like this and then like this and like this and this and this. Okay, so there's a really bad interpretation of what that sketch is supposed to look like. But at this point, now I have the general shape and now I can go back and start to dimension these things. So they said, okay, this needs to be 4 inches. So I just dimensioned that. They said that this one has to be 1 inch. So I'll go ahead and do that. And then they said this one has to be 1 inch, but this is crooked. So it's not flat and level and it's supposed to be. So how do I fix this? So for this, you can end up using another constraint where you can say, this is a horizontal constraint. So this line must be horizontal. So I have this line selected, so it's turned blue. And now I click on the horizontal constraint tool. And now you can see that it's horizontal. Now you could ask, it's like, why did those not have these? Why didn't we have to put those on the add constraints onto them? And the answer is that Autodesk kind of figured out that that's what you wanted to do. So if you notice, I'm going to do something in slow motion here so you can kind of see. If I start drawing a line, what you'll see here is if I'm on an angle, it's telling me the number of degrees that this anchored from the anchored point to the mouse cursor is. And then if I bring it into 90 degrees or 180 degrees, 0 degrees, sorry, then you'll actually see an icon just to the lower right of my mouse pointer. That is that icon for a horizontal constraint. So it'll say, okay, you drew that horizontally, perfect horizontally. So I'm going to assume that you meant that to have this constraint. So if I select these lines, remember, I never used the constraint on this, but I just drew these. Look, it's already got that constraint because it figured out that that's what I wanted. It did another one here that when I came off of this line and went 90 degrees, it figured that out and said, you probably want that to be 90 degrees. But on this one, I messed it up. I didn't make it 90 degrees, so there is no constraint on that corner. Okay, so some constraints get added automatically based on how good of a sketcher you are. So if you don't, then you can, if you didn't get them, then you can add them after. So for this, I'm going to grab this perpendicular constraint, click on the one line, and then the second line that's going to participate in this perpendicular relationship. And so now you can see what I have here is a lot closer to the part that I really want, but it's not done yet. Okay, so I'm going to go and dimension this, make it 1 inch, and I'm going to dimension this and make this 4 inches. Okay, so far I've got a great outline as to what this gusset's supposed to look like. And now I'm going to use the coincidental constraint, grab this origin point, click there once, and then click in the corner. And now I've locked it to origin, and now I have a fully constrained outline of this part. So there are other instructions here that indicate that there needs to be holes in this. So if I pop this open, you can see that for the rivets here, the rivets need to be 3/16 in diameter, and they need to be 1 inch from the edges. So this is saying 3/16 in diameter, and they're spaced 1 inch apart from each other. And the hole centers are 1/2 inch from the outside edges. So from this edge to the center here is an inch, is an inch, 1/2 inch, sorry. Okay. So what are we going to do there? Well, we could manually draw each one of those circles and position them and individually say, take a circle and say, okay, this is that. And I'm going to do 3/16, which is great. You can actually enter in the fraction and it'll figure out the decimal, or you can enter in the decimal. It's up to you. So I could do this and then make, 4 of these across this side and say, yeah, 3/16 there. But that's a lot of work. And I don't want to do all these things and then have to go back and then say, okay, this one here needs to be 1/2 inch there. And then it needs to be 1 inch from this one. And you see, it's very tedious. There is a lot of stuff going on here. If ever you're going down a route like this, you got to be thinking, there's got to be a better way. So, and there is. I don't know if it's the best way, but it's the way that I do it. And so what I'm going to do here is I'm going to undo all that, and I'm going to grab our friendly construction line. And I'm going to grab the construction line, and I'm going to put it across here. Now I'm going to bring this horizontal, so you see the implied horizontal constraint that's going to be applied there. Select that. And now I've placed this whole line. So now I'm going to take this line here and say this line here, the construction line to the edge, what did they tell me? The centers of the holes needed to be 1/2 inch apart, or 1/2 inch from the edge. So I hit 1/2 inch, and now we have a construction line that's locked in 1/2 inch from that edge. I'm going to repeat this procedure for the vertical. Now notice the implied constraint that appears to the lower right of my mouse pointer, indicating a vertical constraint. Now I'm going to take this and go here, and I'm going to set this to be 1/2 inch. And I could do this, but I'm going to show you another trick here. Say, for example, someone isn't sure whether these holes need to be 1/2 inch from the side or 3/16 from the side, but whatever they decide, they're going to have to be the same. So what I can actually do is in the dimension here for where it's expecting me to enter in a value, I can actually take the value here and plug it in. And you see, this is a reference underneath. So this is a dimension of this one here. So if I hit OK or check mark here, you can see now it says FX 0.5. So what that means is it's a referenced or calculated value to another thing. So now if I go and I alter this and I say it doesn't have to, they don't want it ½ inch, they want it 0.375. It not only changes for this construction line, but it's altered this construction line as well, because this references this. So in this way, you can change the shape of these things with changing as few parts as possible. Knowing this, or pieces as possible. Knowing this, what we could actually do is in this one, assign it to this. And then with this one, assign it to this. Okay, so now if I ever want to change and make a new kind of plate, all I need to know is this set of dimensions here. So if I want to make a 3-inch plate, I can do 3-inch, and it's going to make that. And this needs to be 3/4 of an inch, so 0.75. And then this needs to come in 0.5 of an inch. Actually, it's supposed to be 375 if you wanted to. But now you can see that by changing just these values, I've created a whole new plate size with very little effort. Okay, so that's the advantage of constraining things and assigning references. Okay, so I'm going to set this back to the way we were. ½ inch, and then this 1 inch. And so now we're back to where we were. The next part, we're going to continue getting on to these holes. So these holes you can see here, the first one is right in this corner. Well, I've got a nice anchor spot that I created when I did these 2 construction lines. So I'm going to go at the center here, use my circle tool, and draw a circle. Okay, they've indicated that this needs to be 3/16 of an inch, and I've done it again. So I still have construction selected. So now I've drawn a construction circle instead of a real circle. I'm going to Control Z that, then do this, and then draw my circle again. I mistyped. Yeah. Okay, so now I have this circle that's here. Now, if I move this, you can see that it's still green. I tried to get it on the right on the point, but I must have missed. So anyway, so it's got one of the constraints because it's stuck on this one, but it's not stuck on the other one. So I'm going to take this, grab the center, and also constrain it to that line. Okay, so now we've locked in. So now I've got our first circle, and now I'm going to use a trick to really save me some time. And that is to use these patterns. And we're going to get into a couple of these patterns later on in a later session. But the first one I'm going to use is a rectangular pattern. And if you click rectangular, then you'll actually get a dialog that shows up here. The first thing it's going to do, and this pattern is this dialog looks like a lot of the other dialogs that are in Inventor. So it's great to understand how they work. The first thing is they're expecting you to fill in or select a geometry. It doesn't know what you want to make a pattern out of. So this is highlighted and there's nothing selected. So what I'm going to say is I want to make a pattern using this circle. So now you see that this unselected from the arrow, and now this is turned blue. So I've answered its question as to what item I'm wanting to create a pattern of. The next thing I'm going to do is to indicate a direction that I want that pattern to follow. So if I go here and click this, you can see that now it's telling me that the pattern is, you see a bit of a shadowed sort of circle there that's showing me where the next circle is going to go. Well, that's not the direction I want it to go. So I'm going to hit this flip and it's going to go the other way instead. It defaulted to 1 inch spanning between, so that happens to be correct. If I wanted to change this to be 0.75, I can change it so that the centers of the circles are 0.75 inches from each other, but I'm going to leave that at 1. And then this here, I want it to be a pattern. I want 4 of these total. Okay, so in total, including my pattern, how many do I want to make? And so that's what I'm going to do. Now, you could think with the second direction, you think, great, we can come down this one here, but it's kind of not going to work that way. And I'll show you why. If you select direction 2 and select this, you can see that it's actually creating a matrix of these things, which isn't what we want. Okay, so we need to do a second pattern that goes vertically as opposed to doing it all in one step and not. So I'm going to deselect this. And the way you do that is select the direction, so it's highlighted, and then press Control to deselect, just like you would in File Explorer in Windows. To something selected, hold Control, click it, and it deselects. Okay, so that's how you do that. So I'm going to click OK, and now I've got a 4-hole pattern. And now I'm going to repeat that procedure with the rectangular pattern again. So selecting what I want to actually make a pattern of, and then select direction, and then select the line that I want it to go. This time it's going in the right direction, so I don't need to actually flip it. And then in total, I want 4 holes. And I click OK, and now I have that sketch. So now I've got a fully constrained sketch to specification of what's been required. The last thing they asked for is that it be 3/16 thick. So I'm going to click Finish here, and I am going to go over to 3D Model, click Extrude, and you can see nothing popped out like it did before because it's not sure what I want to actually extrude. Because I could actually extrude this from it, which would be weird, but I could do that, but Inventor doesn't know that that's what I want to do, or doesn't know that I don't want to do that. So I don't want to do that. So what I can do once again, is I can hold Control in and deselect this, and then that isn't selected anymore. You see this dialog actually looks kind of similar. It's saying, select me a profile. In the rectangular pattern dialog, it says, select me a piece of geometry. So it's kind of asking you questions that you fill in. So I'm going to say, select this profile. And it's going, great. Now tell me how big this needs to be. Well, that's 1 inch thick. That's a pretty big gusset. So instead, I'm going to make it 3/16 of an inch. And you see now it's created me that plate. Okay. These other things we'll get into in a later session. But for now, click OK. And there's our plate. Any questions on that? So that's as much material as I think I'm going to cover today. I hope this was useful. If there are things that you aren't sure about or didn't catch on the first time through, we will be publishing a YouTube video for this, so you can go back and watch it and listen to it. If you have classmates that maybe didn't attend, that maybe really were interested, or they had exams or something like that, please let them know that this training is here, and that they can also catch up on the first session watching the YouTube video. And then secondly, this is going to build on each lesson. So if you end up wanting to take the second session, or if your friends want to take the second session, encourage them to watch the YouTube video before, so that otherwise they're going to be lost, because I'm not going to go over the same things that we went through in this hour. So use the first session as you want, and then promote it to your friends if they want to attend the second session. And I think we're planning on next week, same time.
Thank you, Steve. Any other questions that you might have after the fact, There's also the Discord server where you can ask questions, and then we will, any of the mentors will be able to answer them. I'm going to stop the recording.